All right, let's talk about something you use probably hundreds of times a day, but I bet you don't really understand it. I'm talking about web cookies.
Look, you've clicked accept all on those banners a million times. We all have. But what if I told you that your whole idea of a cookie, as some little file on your computer that stores stuff, is fundamentally missing the point?
It all boils down to this one simple question. Is a cookie's job storage, like a digital notebook, or is its main purpose communication, a way for you and a website to talk to each other? Because honestly, the answer changes everything about how you should think about web security.
Okay, let's get into the weeds just for a second. Here's the textbook definition. A server sends your browser a small piece of data. Fine. But here's the part everybody misses, the absolute key. Your browser then automatically sends that little piece of data back to the server with every single request. It's not just sitting there. It's an active, constant conversation. And this is where the light bulb really goes on. Think of something like local storage as a notebook you keep in your backpack. It's for your notes, for you to look at. A cookie? Oh no. A cookie is your official ID badge. Every time you try to open a door on that website, you have to show that badge. It's your pass. It's proof that you are who you say you are for that session. So if we're running with that idea, that a cookie is your ID badge, that brings up a pretty scary thought, doesn't it? What happens if that badge is super easy to steal? What if someone could just snatch it and start walking around the website pretending to be you? Well, this leads to two huge security nightmares. First, you've got cross-site scripting, or XSS. In our little analogy, this is like a thief literally snatching the ID badge right off your hip. The other one is cross-site request forgery, or CSRF. This one's a lot sneakier. This is like someone tricking you into tapping your own badge on a door you never, ever meant to open. Okay, so this ID badge is clearly powerful and, well, pretty dangerous if it falls into the wrong hands. How do we protect it? Lucky for us, we have a toolkit. They're called security flags. First up is the absolute MVP of cookie security, the HTTP-only flag. The rule is dead simple. When this flag is on, no client-side JavaScript can see or touch the cookie, period. That means a hacker's nasty script can't read it, can't copy it, can't steal it. Just like that, you've shut down that whole badge stealing problem. Next, we've got the secure flag. This one's just as simple and just as crucial. All it says is, hey, this ID badge can only be shown in secure encrypted hallways. In web terms, that means it's only sent over HTTPS, never plain old easy to eavesdrop on HTTP. But what about that other attack? The one where someone tricks you into using your own badge. To stop that, we have our third hero, the same site attribute. This one is all about controlling when your browser even bothers to show your ID badge. So, same site has basically three modes. Strict is like Fort Knox. Your badge only works when you're already inside that website's walls. Then there's lax, which is the default these days, and honestly the sweet spot. It lets you use your badge when you click a direct link to the site, say from an email. And none? Well, none lets your badge be shown all over the place, which is something you'd only want for stuff like cross-site ad tracking. So where do you actually see these ID badges in action? Oh, they're everywhere. The number one use is keeping you logged in. That's your session ID. It's how a news site knows you've read 2 of your 3 free articles this month. It's how your shopping cart remembers what's in it. And yep, it's how those ads for sneakers you looked at once seem to follow you across the entire internet. All right, so let's put it all side by side one last time, just to make it crystal clear. Local storage is the notebook. It's for client-side stuff. The server has no idea it even exists. Cookies are the ID badge. They're all about talking to the server. They're tiny, about 4 kilobytes, precisely because they get sent with every single request. The notebook is for you to remember things. The ID badge is for the server to remember you. And that brings us to the single most important, most actionable thing I'm going to say in this entire explainer. So please listen up, especially if you're a developer. For your user's authentication, stop storing tokens in local storage. Why am I so passionate about this? Because, as we now know, local storage is just an open notebook on the table. Any malicious script that gets on your page can just flip it open and read the login token. But an HTTP-only cookie? That same script can't see it. It's like it's in a locked box that only the browser and the server have the key to. So, what's the perfect setup? What is the absolute gold standard for authentication on the web today? It's this right here, this beautiful combination. An HTTP-only cookie, so scripts can't steal it, a
a secure flag, so it's only sent over encrypted channels, and same site equals lax to prevent other sites from tricking you into using it. That is the holy trinity of modern session security.
So let's wrap this up. What are the big takeaways? 1. Cookies aren't for storage. They're your ID badge for communicating with the server. 2. Because they're your ID, they're used for super important stuff, like keeping you logged in. And 3, most importantly, an ID badge this powerful has to be locked down with the right security flags. HTTP only, secure, and same site.
So I'll just leave you with this final thought. The next time you log into your bank, your email, whatever, just pause for a second and ask yourself, is my digital key, my token, being kept in an open notebook for anyone to read, or is it secured on a locked down ID badge? Because now you know the difference, and you definitely know why it matters.